And yeah, with this session 2, we will jump into practice and into ALDREN practice. Within the ALDREN project, there is a huge work that has been conducted on implementing the ALDREN protocols on a large set of pilot studies over Europe. And Christophe Gérard from Certivéa coordinated the work for the consortium on these pilot studies. Christophe, the floor is yours. Please introduce us to the main results.
Okay, thank you. Good morning, everyone. My name is Christophe Gérard, and I am the Scientific and Technical Director of Certivéa. Certivéa is a subsidiary of CSTB, and we are a certification body in charge of delivering HQE's voluntary certification scheme for all non-residential buildings. And our role in this project was to develop first the 2.5 evaluation protocol about financial value, and then to coordinate the pilot phase of the project. Next, please. So during this presentation, I will give you some details about pilot buildings, the main results we obtained on these buildings, and the main feedbacks we have and improvements we have with these pilot studies, and some perspectives about market uptake after ALDREN project. Next, please. So during this project, we had 20 pilots in 6 European countries, 14 offices and 6 hotels, and we managed to have all renovations phases, decision, design, works, operation. The average gross internal area was around 11,000 square meters, which are rather big buildings, and we managed to apply all the tasks developed in ALDREN. Next, please. So a few words about the time frame of this pilot phase. First, we register the pilot buildings, and that took a lot of time to find the pilot buildings and then to explain the pilot phase and to finally register the buildings. Then the most consuming time phase was the data collection phase and the test, because essentially because of a lack of knowledge about on buildings, and then we test the different protocols until June 2020, and then we have meetings with pilot buildings to explain the results between July and this September. Next, please. So as you can see, and as I said before, we managed to apply all tasks, and each pilot represents one piece of the renovation process, not covering the entire ALDREN procedure. We tried to test as much indicators as possible for each pilot, but as a minimum, it is through the sum of the 20 pilots that the whole ALDREN procedure has been tested. So you can see that, for example, we test the tail index on 11 buildings, and for example, we test the gap between calculated and actual energy performance on 7 buildings. Next, please. So what are the main results? Here you have the energy savings triggered by the project during the project. So this energy consumption is only for the end use of European directive on energy performance of buildings. So this is about heating, cooling, lighting, ventilation, and hot water only. So you can see that we reach an average gain of 120 kilowatts in primary energy per square meter a year, and which corresponds to a gain of 3 to 4 places on EVC rating, and we managed to reach class A or B for the majority of buildings we test. You can see also in the table in the left of the slide the average consumption before and after for hotels and offices. So for hotels, the average values are around 110 gains for between before and after renovation. And for hotels, this is a gain of about 150 kilowatt-hour per square meters a year. These results are very promising in the sense that studies were not really conducted with design teams, but in parallel of their work, and because of the time frame of ALDREN and of the time frame of building projects. Next, please. Another one result about the renewable energy production triggered by the project. We managed to have a lot of PV plants on roof and balconies for hotels. One building was also connected to a district heating network. So we managed to have a lot of improvement of this energy production during the project. And this is due to the fact that a majority of pilot buildings are also in very hot climate, especially in Spain for the hotels. And we managed to implement a lot of PV panels artificially PV panels on these buildings. Next, please. Some results about investment costs. So we saw that first, the costs considered here are only the costs generated by energy renovation actions. And we don't consider, for example, costs for works related to comfort or to aesthetic services in the building. So you can see here that there is a lot of differences between geographical zones, and as you can see in Paris, the average investment cost is about 500 euro per square meters instead of Bratislava 250 euros, and so on. These results are based on cost of comparable projects, national database, and professional costing studies also. So this is due to, certainly to the difference in the cost of labor and materials in these different geographic area, for example. Next, please. Other results about the application of the TEL index. What can we say? We can say that in existing buildings, because we apply TEL before renovation in existing buildings and by measurements. So we saw that there is a very poor indoor environment quality in existing buildings all over Europe, whatever the typology of the buildings or its geographical location. We have all the buildings in low quality, except one, which is in moderate quality. And I think this is because the overall TEL score is the lowest class of the 4 components. But the main conclusion is that indoor environment quality is poor in existing buildings. Previous slide, please. No, this one. Okay. This one. So 4 major points about feedbacks brought by pilot studies. First is that there is a lack of knowledge on existing buildings in Europe. which very often poor technical data quality, especially for in-use building, because of a lack of meters. Second point is that financial data is very sensitive and not easy to share, and that was very difficult for us to obtain this data. Third is that the earlier you engage ALDREN, better is the result. So we have to, the design teams have to apply ALDREN from the start of the renovation. And fourth, trainings are necessary for the future in both financial and technical fields addressed by ALDREN. The next slide about the main improvements of ALDREN protocols brought by the pilot studies. And of course, this pilot phase allows us to improve all the protocols and tools developed in ALDREN. As you can see, for example, we optimize the EVC scale, the European Common EVC scale, especially for hotels. We adjust tail protocol. We optimize the assessment of class of performance verification tool between real and modeled energy consumption. We adapt also the financial valuation protocol for hotels. We confirm with this pilot phase the structure of the build log. We adapt also the interactions matrix of the RenoMap, and we finally adapt the final model of the BRP. Next. So what were the main interests of pilot buildings owners in ALDREN? First, it helps them to have a better knowledge of their buildings and their operating. They were very interested in to have a clear vision of possible performance and renovation actions to reach this performance in a time frame with the RenoMap. They were interested also to use ALDREN to be competitive in real estate market compared to neighbor new buildings in terms of energy performance, health, and comfort. And they were also very interested in the link between renovation actions and cost value of the building to discuss with investments and property funds. And finally, next, the conclusions are very positive conclusions for the different stakeholders that can be interested by ALDREN. First, the owners say us that they are ready to apply some of all the ALDREN protocols on some other buildings or all their buildings. The design teams, consultants are interested to use ALDREN modules in regards of their specific needs. For example, energy consultants are very interested in the task 2.2 and 2.3. Other consultants or owners are very interested in tail, for example, in order to give the users of their buildings an evaluation of the indoor environment quality of their building. Certification bodies, IVE and Certivéa, but also others like BREEAM and DGMB are interested in using tools and protocols developed by ALDREN as parts of requirements or guides in their own environmental voluntary certification schemes. And Certivéa is also interested in delivering the EVC rating and guaranteeing the quality of this EVC rating in Europe. And finally, training companies are also interested to develop trainings on the two fields, technical field and financial field, which are the two main skills necessary to apply the ALDREN protocols. Thank you for your attention. This was very quick to give all the results of the 20 pilots, but if you have any questions, I'm here.
Thank you very much, Christophe. Thank you for this overview. Yeah, you are right. Yeah, to ask for questions, and please, participants, don't hesitate to share yours. Yeah. By now, we will welcome Corinne Mandin from TSTB. Already had many questions regarding health and well-being and the tail procedure and indicators that have been developed. Corinne is going to explain us further on this approach, health and well-being and tail, through the implementation on pilot buildings. Yeah. Corinne, floor is yours.
Thank you very much, Mathieu. Thank you. Good morning, everyone. So it's my pleasure to introduce a few results about the application of tail to the ALDREN pilots on behalf of all the ALDREN partners. Next, please. So as introduced by Pavel Vargotsky earlier this morning, the ALDREN tail index is addressing 4 major components of indoor environmental quality: the thermal environment, acoustic, indoor air quality, and light environments. Beyond these 4 major components, we have 12 parameters that I will show you again in a few seconds. And based on these 4 major components, we can assess overall quality of the building in 4 categories. Next. So once again, you have already shown this parameter this morning, the 12 parameters including in tail. They can all be measured, except visible mold that is observed, and some can be modeled if needed. Next. So each of these 12 parameters is assessed according to 4 categories. These categories are defined by the standards or by the World Health Organization, as we discussed during the discussion. For example, for formaldehyde, benzene, or radon, we are using the different WHO guidelines that exist. So the 4 categories are between category 1, green, the high level of quality, to category 4, red, the poor quality. So each indicator is associated to a category at each monitoring location in the building. Next. So tail must be determined before and after renovation to be compared. And since we know that there is a seasonal effect, that there is a seasonal variation of indoor environment quality, to make a proper comparison, measurement must be made at the same season before and after the renovation. This is important for the comparison. And another important point is that to capture the typical condition of the building operation, the building must be absolutely operated and occupied as usual during the monitoring. Next. So regarding the number of sampling locations, of course, we cannot measure everywhere in the building. This would be too complicated and too expensive. So we made a compromise between the representativeness of the sampling location and the technical and economic feasibility. And this compromise is to instrument between 2 rooms in very small buildings and 10 rooms. And these 10 rooms must at least represent 10% of the occupied area of the buildings. Next. So once again, since we cannot measure everywhere, we measure preferentially in places that are occupied all the time by the occupants. It means in office buildings, and in rooms in hotels. We exclude the meeting rooms or the lobby, for example. And we must have a diversity among the sampling locations. So for example, we choose the lowest occupied level in the building and the highest. We must choose different orientation, rooms oriented to the street and rooms oriented to the garden. And if there are different types of offices, single offices and open plan offices, we must have a mix of all these different locations. And once again, all rooms must be normally occupied. Next. And the duration of sampling is different according to the parameters. It is 1 month for temperature and relative humidity, 2 months for radon according to the standard, and only if the building is in a radon-prone area. And for all the other parameters, this is 1 week, from Monday to Friday in an office building, a typical working week. and from Monday to Monday, or Tuesday to Tuesday, or Wednesday to Wednesday in an hotel. Next. So you see on this slide the monitoring equipment that is used for characterization of tail. So from temperature data logger to passive samplers that are used for gas, formaldehyde, benzene, radon. For particle, we are using either active sampling with a pump, it means a gravimetric measurement, or particle optical counters that are more easy to use for particles. And for noise, we are using a noise meter and lux meter for lights. So all this equipment must be put in the center of the room and must avoid direct sun or heating to disturb that would disturb the measurements. Next. So to facilitate the calculation of tail, we have elaborated an Excel sheet where you only put your the value, your measurement in the blue cells, and all the calculation is done automatically for each parameter, and finally for the tail, as you can see on the next slide. You have, at the end, they directly calculated the tail score for the building. So next. So on the next slide, you will see the results for the, yes, thank you. So the result of the tail calculation for the 6 office buildings and 5 hotels across Europe included in the ALDREN project. So you can notice that there is a diversity for temperature, indoor air quality, light, and light being the best parameter. But we observe a common feature for all the buildings means a poor acoustic environment. So this is something that needs to be targeted for the future. Next. So what we learn from this pilot, we learn a lot. We learn that the method we propose is applicable. It's not too complicated to do. It's classical measurements. We made some adjustment for the rating because we were a bit strict at the beginning. So we adjusted this to be more accurate in the evaluation. We observe that we have differences across the building. So this is good. We need an index that is discriminant. So this is positive. And we are able also, thanks to tail, to identify weaknesses in the building, so to identify potential for IAQ improvement during the renovation operation. So this is very useful for the building owners. Next. So this is not the end of the story. We have in mind many development for tail in the future. On a very short term, we want to do more sensitivity analysis on larger data sets because 11 building is too small. So I make a call today. If you have data that you want to share with us, this will be a pleasure for us to calculate tail on your data sets to make it more robust. We are thinking of adding new parameters, for example, the inclusion of the occupant rating. We plan to extend tail to other buildings, such as schools or dwellings. We are currently developing a framework for the prediction of tail according to different renovation strategies. We cannot measure, by definition, tail after renovation before having renovated, but it's useful to predict what could be the tail after to make the best choices, to choose the better renovation strategy. So this is what we are developing right now and what we are calling predicting. We plan to monetize tail to give more to have a stronger evaluation, to give more strength for the building owners, for the financial analysts to convince them to renovate. And the last point is we would like to develop a simple measurement box to make the measurements be easier. So thank you for your attention.